The third and final form of a quadratic that we're going to show you is what we call intercept form. And we learned standard form of a quadratic, which was similar to polynomial standard form, and then we learned vertex form, which simply gave us directly the vertex of the quadratic. This time we call it intercept form because what the intercept form is going to do is it's going to give us our zeros of the function. It's going to give us the x-intercepts directly. Now, very similar to vertex form, you can see here we're going to use a P and a Q to represent our x-intercepts in this particular setup. Now, the A value does just like it did before. Positive or negative opens up or down. Bigger or smaller makes it steeper or wider. So that acts the same way as it did before. However, the P and the Q are going to act just like the x minus h did. So it's going to be opposite of those, whatever those values are. And we're going to pair up the P and the Q with a 0 to create the actual x-intercepts. Now, very important concept here is that we know that those points are on opposite sides of the quadratic function because they're symmetrical across the axis of symmetry. And so since that's the case, if I mark these 2 points, we know that that axis of symmetry has to run halfway between them. This is going to give us an x value of some number, and that is going to be the x value of the actual vertex. And so that's technically what we need to find last. Since we can basically are given the intercepts, we just need to find the axis of symmetry and then the vertex. And so you can see here in example problem number 3, we're given x plus 2 and x minus 4. Of course, the negative in front of this tells me that it's going to be opening downward. So I have a visual idea of what the graph should look like. And then we can just simply find our P and Q values and create x-intercepts. And so you can see here we have negative 2, 0 and 4, 0. And of course we can simply plot those on the x-axis. Now, those will be a certain distance away from each other, and in this case we're looking at roughly 6 units away from each other, so the axis of symmetry has to be in the middle of that, or roughly 3 units away from each point. And so once we identify that axis of symmetry, we then know that the x value lies at 1, and that is going to be the coordinate of our vertex. And so we can simply evaluate this function for 1, and it'll give us our y value. And when we do that, we have a y value of 1, 9, or excuse me, about y value 9 and a vertex of 1, 9. Now, if you look really closely at this graph, the vertex is an awful long ways away from the x-axis, and so we could probably sketch this pretty comfortably without having any additional t-chart points. Now, if you wanted to, you could be more than glad to t-chart a couple extra points and get a little better visual. Now, I'm going to recommend to you, the closer and closer that vertex gets to the x-axis, the more t-chart points you're going to want, just simply because it'll give you a clearer picture. And we may see that in a later example. So go ahead and move on down the notes and work the next set of sample problems using intercept form.